There are currently around 120,000 people on the waitlist for a life-saving organ transplant. 20 of those people will die each day waiting for their transplant due to the lack of available human organs. In order to save more lives, a viable alternative to traditional human organ transplant is needed. This is where xenotransplantation, or using pigs as organ donors for humans, can help. The ability to use pigs as organ donors can create an unlimited supply of organs, tissues, and cells to be used as an alternative to human organ donation, helping eliminate the wait list and ultimately saving lives. Now, you might be thinking, what's keeping pig organs from being used in transplants? The simplest answer to a very complex question is that pigs look different than humans. I mean this beyond what we can see with our eyes on a visual level, I'm talking about on a cellular level. Our immune systems look for these differences to protect us from infection. The problem is that when our immune system sees these differences on a transplanted organ, it leads to transplant rejection. The most common way that organs are rejected is through a process called antibody mediated rejection. Antibodies are Y shaped proteins that are created from cells in the immune system called B cells. Antibodies work to protect us from infection by recognizing, binding to, and ultimately killing cells or pathogens. So, when a patient receives a transplant, their antibodies would recognize this newly transplanted organ, bind to it, and then kill it. My research focuses on studying how to overcome antibody-mediated rejection in xenotransplantation. We will do this by addressing three aims. First, we want to establish reliable and consistent antibody screening tools. Second, we want to determine what the antibodies are targeting on the surface of the pig cells. And third, we want to identify the source of the antibodies, or what cells are creating these antibodies. By developing reliable and consistent antibody screening tools, we can select patients that have the best response to each of our donor pigs, giving us the best chance for long-term organ survival. Second, by determining what the antibodies are targeting on the surface of the pig cells, we can then use genetic engineering to remove these targets from the pig cells, helping increase the life-saving potential of the transplanted pig organs by making them look more friendly to the human immune system. Third, by identifying the source of the antibodies, or which cells are creating these antibodies, we can then use more precise medications to help protect the organs from these antibodies, again, leading to longer transplant and better transplant outcomes. Together, this research aims to improve the viability of xenotransplantation for use in human transplants so that we can help take the over 120,000 patients off the wait list and save their lives.